Let's try a couple of more nonlinear inequalities. In this particular problem, we have a nonlinear inequality in the form of a quotient. Now, the first one says factor on one side, get a 0 on the other side. Well, we've already got a 0. The bottom already has a factor. What we need to do is factor that top. So we factor the top, we get x minus 3 times x plus 2, and the reason that I did it in advance was because this podcast was taking too long, so I had to save some time. Now notice my individual factors. To make the first factor 0, x would have to be 3, so that's my first critical number. To make the second factor 0, x would have to be negative 2. There's my second critical number. To make the bottom factor 0, x would have to be negative 1, so there's my third factor. And then I graph negative 1, negative 2, and positive 3 on the number line. Now notice that since I have 3 critical numbers, I now have 4 intervals. The number of intervals is always one more than the number of critical numbers. The first interval goes from negative infinity to negative 2, the second one from negative 2 to negative 1, then negative 1 to 3, 3 to infinity. The critical numbers determine the intervals. Well, let's do our tests now. We're going to have 3 numbers. We're going to have a quotient, and we're going to want to know, is the quotient negative? And it's negative if it'll have an odd number of negatives. So let's try a number. I go into the first interval, and let's say that I pick negative 10 for my test number, because that's certainly in that interval. Then this first number, negative 10 minus 3, is negative. Negative 10 plus 2 is negative. Negative 10 plus 1 is negative. So I get negative times negative over negative, and that's 3 negatives, so the answer is negative. It's supposed to be negative. There's my first solution interval, negative infinity to negative 2. Now about the only good number to try here is negative 1.5, and that's a little bit trickier to use. But let's give it a try. Negative 1.5 minus 3 would be negative 4.5. That's negative. Negative 1.5 plus 2, the 2 is bigger, it's positive, so that's going to be positive. Negative 1.5 plus 1, the 1.5 is bigger, that was negative, so that's going to be negative. 2 negatives, though, give you a positive. And a positive is not less than 0, so that's not a solution interval. Let's try the third interval. Since the third interval goes from negative 1 to 3, 0 is in there. Now when you plug in x equals 0, that's really great. 0 minus 3 is negative 3, which is negative. 0 plus 2 is positive 2, which is positive. 0 plus 1 is positive 1, which is positive. So I have one single negative. An odd number of negatives makes it negative, and it's supposed to be negative, so there's a second solution interval, negative 1 to 3. And the final interval is 3 to infinity. Suppose I pick 100. Then the first number is positive, the second number is positive, and the third number is positive, and the whole thing's positive, so that's not a solution interval. Now the only thing left to check are the endpoints. I know that the endpoint on the negative infinity is round because negative infinity isn't a number. Let's check the negative 2. In our problem, this quotient is allowed to be 0. This says it's less than 0 or it's equal to 0. If I plug in negative 2, I get a 0 on the top. A 0 on the top gives me 0. So negative 2 is a solution, so I put a square bracket indicating that negative 2 is in the solution set. Now negative 1 also makes me a 0, but there's a difference. Negative 1 makes me a 0 on the bottom. Zeros on the bottom are not allowed. That makes it undefined, so that is not a solution. But the 3 makes a 0 on the top, so that is a solution. And my final answer is negative infinity to negative 2 union, negative 1 open to 3 closed. Okay, let's take a look at another one. In the first problem and in the problem on the previous podcast, the right side was always 0, which is what we wanted. In this problem, We don't have a 0 on the right. So what we do is we subtract 2 from both sides to take us to this equation. That gives me my 0 on the right, but now I don't have a product on the left. So I've got to have a way to get this into the form either of a product or quotient. So what I'm going to do is I'm going to add these together and see if that helps. To do that, I'll need a common denominator, so I take my negative 2 and I multiply it by x minus 1 over x minus 1. And that gives me this equation down here, x minus 2 times x minus 1 over x minus 1. When I distribute and I group things together, I get negative x plus 2 over x minus 1 is greater than 0. So this is the quotient now that I'm going to be testing. My critical numbers, well, if I let x be 2 on the top, I get a 0. So 2 is a critical number. If I let x be 1 on the bottom, I get a 0. So 1 is a critical number. So I graph my critical numbers 1 and 2. And that's 2 critical numbers, so I get 3 intervals. And this interval goes all the way out to negative infinity, so the first interval is negative infinity to 1, and it contains 0. The second interval is 1 to 2, and the third interval is 2 to infinity. Now what I need is a checkpoint from each interval to plug into the equation negative x plus 2 over x minus 1. So since 0 is in the first interval, I plug in a 0. And I get negative 2 over negative 1, which is positive. I'm supposed to be positive, so that's a solution interval. First solution interval. I'm sorry, that's supposed to be a plus 2. Oh, messed it up. That's a plus 2. So let's try that 0 again. If I put a 0 on the top and I have a plus 2 on the top, then that's positive 2. Positive 2 over negative 1 is negative. And it's supposed to be positive, so that is not a solution interval. The best number to pick in the second interval would be 1.5 positive. So let's see how it would work out over here. If I add 1.5 to 2, that's certainly positive. If I have 1.5 and I take away 1, that's a half, and that's positive. Positive over positive is positive. It's supposed to be positive. That's a solution interval, 1 to 2. I go to the third interval. I pick a 10. Oh, and that's supposed to be a negative x there. I pick a 10, so that's a negative 10 plus 2, which is negative, over negative 10 minus 1, which is negative. Negative over negative is positive. That does not ring true to me. Let's see, if I pick a 10, I get a negative over a positive. If I pick a 10 for x, the bottom is not negative, it's positive. It's a 9. So I get negative over positive, which is negative, so that is not a solution interval. So my only solution interval was 1 to 2, and I now have to think about whether those are closed or open, whether it's a round bracket or a square bracket. Well, I try the 2. If I put the 2 on top, I get a negative 2 plus 2 on the top. That gives me a 0 on the top, which would be okay if my sign was greater than or equal to 0. But my symbol is strictly greater than 0. And if I plug in a 2, I'm going to get 0. Can't do that, so that's not part of the solution. Round bracket. My 1 makes a 0 on the bottom, even if it had been greater than or equal to. I could still not use the 1 because you can't have a 0 on the bottom, so that's not a solution. So my final answer is 1 open to 2 open. Open means round bracket, closed means square bracket, and that completes the podcast.